Fantastic. So my name is Taylor Perkins. I'm a backend developer at a company called, well, for the past year I've been a backend developer at a company called iCitizen here in Nashville. Handle a lot of data, write APIs. Currently transitioned over to a company called Teacher Finder, where I'm a full stack developer for them. That's within the past week, actually. But I'm going through Nashville Software School, their data science cohort. We've been doing that since October. And this is my project on Spotify. They have a song analysis API, and I leveraged that. So who am I? Went through this a little bit. I'm a musician by heart. Been in several bands since I was 15 years old, all through my high school and college years. I'm a software engineer, data scientist. I also have 2 parakeets. I love them very much, and they love each other. So my overall question was, given the top 100 ranking songs from the Billboards API, for every week between the years 2000 and 2017, what are some trends in the type of songs being played based on song details from the Spotify API? And so this was really interesting to me. Being a musician myself, I'm obviously interested in music. I want to know why my band sucks and every other band is great. So what are some information from the Spotify API specifically? Echonest. So Spotify purchased this tool a few years ago. Echonest essentially, they have a deep dive in the audio analysis MP3 files for different songs. It's really, really interesting stuff. Echonest defines specific features for a song. This is kind of debatable, so take it with a grain of salt, but acousticness levels, danceability, energy, instrumentalness, liveliness, speechiness, and valence. These are the fields that I was really interested in. All of these fields are a number between 0 and 1. It's like a confidence level. So, for example, like energy, the higher it is to 1, the more likely it is to be energetic. You would think of like death metal or something like that. Whereas 0 would be like super acoustic, maybe like a Bach prelude. So that's what I was really interested in. And so in addition to that, I have the dates, I have the artist, songs, and the rank of that song for every given week. So that's what I used. And so now we go over to my presentation. So at this time, this is like our 3rd through 6th-ish month at the data science cohort. We're studying R. I'm not a huge fan of the language myself, but being a Python developer. But we built out this Shiny dashboard. So I really wanted to dig into the layout of Shiny itself, try to understand the dashboard concept, be able to play with some of the filters, and overall just do a high-level approach at some of the features from the Spotify API. So here on the left-hand side, I have some different filters set. You can do date ranges, and these ranges, well, essentially all these filters will be really interactive with the graphs to the right-hand side, so you can click through it and it'll adjust. So if we want to change this to maybe something like 2015, maybe. Let's try this instead. Ooh. So this is from 2000 through 2014. Now, you can choose specific Echonest fields. These are the 7 fields that I described earlier, acousticness through valence. I also have the definition of what those fields actually mean according to Spotify documentation. So like acousticness is a confidence measure from 0 to 1 of whether the track is acoustic. 1 represents high confidence the track is acoustic. You can also adjust the field ranges. So since it is between 0 and 1 for every single one of those fields, you can compare them against each other, and you see the graph to the right. If you wanted to, like me, I was kind of, I guess, concerned at what Spotify would assign those values to those songs. And so I wanted to embed an iframe for the Spotify songs specifically, so I could kind of better understand what it actually means to be highly acoustic or not, or at least what Spotify defined them as. So we can definitely listen to Justin Bieber if you guys want. I prefer not to, but in this case, Justin Bieber was the highest acoustic song. Based on those filters as well, I have the most frequent artist and the highest scored artist. The scoring I came up with on my own. It's a blend between rank and the frequency that the artist or the song appeared. So I have that for both artist and song. And to the right, this is just a frequency plot of all of the different levels for acousticness specifically. Like I said, over here on the side, you can adjust this and change whatever you want to. So in this case, now it's energy. you have Miranda Lambert and Five Finger Death Punch, which is awesome. You also have a box plot. This is just over every year. You also have the quartile ranges, you have the medians, some specific outliers if you wanted to dig into that. But this allows you to spot some of the trends over time. Maybe if the median goes up or down, you can kind of see on average what's going on. And then this is a line graph over all of the time. This includes all the different fields from acousticness through valence. This is just an overall summary of everything all together. This one's not specifically set up to align with the filters that I set on the left-hand side, but this one kind of goes on its own, and you're actually able to adjust all the dates, and the graph interacts and kind of flows through with that. So if you're interested in one point in time, you could kind of specify that, like right there is a really low point, and you can see that, you know, the instrumentalness was like at an all-time low for that period of time, so it's really just bringing the averages of everything else down. That was really interesting. I used the high charter as well. That was one of the graphs. Well, that was one of the tools that I use for my graphs. They really are great with like stock type graphs. And this is like a one-line code to do this. I also included a data set of everything that I had. This included the date, artist, song, all the different levels. So if the user wanted to go through and search that themselves, they can. And also you can click on these and it'll bring up the Spotify track for each individual song if you wanted to see that as well. So that's essentially my project. Yeah, so that's everything. So you guys have any questions?
What did you learn about your band versus
My band is not poppy enough. Anybody else?
Yeah, so yes, do you have any sort of, I know you were doing some sort of sanity check.
Yeah.
Where you were looking to see what is does acoustic really align with what I think acoustic is?
Sure.
All of that. Do you see any that were extreme, I guess, in multiple categories?
It's not, I mean, it's hard to define what acousticness is. I can't do it. I don't really know how Echonest does it necessarily. But that was the value that was given in the Spotify API, and I take it with a grain of salt. That's why I included the iframes in there so that you can see it yourself. Like, this is what Spotify assigned, not necessarily myself. So it wasn't completely accurate. It's hard to compare like between like 60 and 70, or like 0.6 and 0.7. Like, you're probably not going to notice much of a difference. Between 1 and 0, you'll definitely notice a difference. Between 1 and 5, you'll notice a difference. So yeah. Anybody else? Paulo?
Yeah, so it just occurred to me, this question just occurred to me, you can check to see what the profile of the most popular song is at a point in time, right?
I would like to introduce that feature. That's not on there quite yet, but
Okay.
yeah.
So, but at a point in time, you can check to see, I guess, like the spread of the songs that are played the most. You know, like, are there more acoustic songs, or are there more dancey songs?
Yeah, absolutely.
Did you ever look into if there was like a notable change after like some big like national event or something?
I did not get into that part, but yeah.
Presumably you could totally do that.
That would be really interesting to be able to create some sort of historic overview of like this happened, and so there's more poppy songs or more energetic songs or whatever. Yeah, that'd be really interesting.
Okay.
So you had some troubles with R?
I don't like R. I think it's a pretty immature language. For myself, I'm a backend developer and I build architecture for web APIs, and so to me, R is not at that level, and it was really hard to, especially for some of the plotting, like the package that I use, High Charter, it was kind of hard to ingest metadata into some of the plots that I was pointing out, like the artist name or song name or whatever. Like, I'm used to a JavaScript library called D3 that you have like full control over everything. It's really, really nice. And there's a lot of restriction with some of the R packages that I found.
Is there anything you liked about R?
No, not really. I will say, like, be able to create a UI and a server in one language and spin that up really quick if you want to do something kind of more high level or in depth in some cases. You can do that really quickly, and that is a really nice feature. Like for me, if I were to create a project, usually I would spin up like a Flask API or Django and use JavaScript and D3. And that, I can do that, but that will probably take a little bit more time and you have to juggle multiple languages. So R is really nice for doing that. Yeah. Anybody else? All right, thank you guys.